Hi everyone, this is Nandakumaran with another video in the series in the Kafka series. So today we are going to see what is Kafka and why it is used for. So let's start with a simple diagram where I can explain a new term to you. Consider there is a box. Let's name this a magic box. There is a circle back and forth. The circle will push some data to the magic box. This circle will pull some data from the magic box. The circle which pushes data is known as producer, and the circle which pulls data is known as consumer. Don't worry, we will see what a producer, what a consumer in separate videos. For just understanding, circle will push data to the magic box. This circle will pull data from the magic box. This magic box here, it is known as Kafka. We are going to see a lot of things around this now. So let me wipe this down. Yeah. So we are going to see first the key details about Kafka. These are the things which makes Kafka better. So the first point is it is massively scalable, which means it can handle a lot of data in a second. So to be precise, it can handle around 1 million messages per second. Let's grab our magic box example. Let's have the two circles. One is producing, another one is consuming. Consider there are 1 million producers or 1 million circles producing one data per second. In the same way, consider there are 1 million consumer consuming one data per second. This is the layman term to understand how Kafka handles the traffic. So the next obvious question is how long the data will go from the producer to the consumer. In other words, if I push something, when it will be available to the another side. So that's our second question. For this, it is having an extremely low latency, which means if I push something to the magic box, means it will be available on the other end in less than 2 milliseconds. It's damn fast. So the next point is high fault tolerance. For those who don't know what a fault tolerant is, if consider you are using a web application, at some point you might face the website is not working or it not responding, means that is something they need to take care on the fault tolerant part. Actually, it is not available for the consumer for a certain amount of time. It might be a week, it might be a month, it might be in seconds too, but it needs to be up in a majority of time to maintain the good thing with the consumer. So how Kafka handled it is it uses in-sync replicas, which means consider we will have another magic box along with this thing. If a message is pushed to the magic box, it will have this thing here. Whatever the messages are here, it will be available in a replica which is in the same cluster or in the different cluster, it doesn't matter. So once at any point, if this server goes down, the producer will start producing this magic box, and the consumer will consume from this magic box. This is how it manages the high fault tolerance architecture. Then the geographical distribution of the clusters. Each cluster can be distributed geographically around the world, so that the user can connect with the thing which is nearer to their location. If I am in Chennai, means I can if some cluster is in the Mumbai, means it will be it can be reached faster, consider with an server or cluster which is in North Virginia. That's the case with the geographical distribution. So if you understand this, we'll move on to the next one. So now we are going to see what Kafka is. So according to the definitions, Kafka is an event streaming platform and it uses PubSub messaging system. So let's break these terms. Before that, we need to check what an event is. Event is known as something happened. Let's say you are in an online transaction portal. Your name is Riazur. So you are transferring $100 to Sanjay. So the transfer of money from your bank account to his bank account is known as event. This needs to be processed or streamed to the server, so that from the Riya's bank account the balance will be reduced, and in Sanjay's bank account the balance will be increased. So to handle this, we can use Kafka in the banking systems. So next we are going to see what a PubSub messaging system is. Before going to the PubSub, we need to take care of the messaging system. Actually, there are two kind of messaging system. One is point-to-point messaging system and another one is PubSub messaging system. A point-to-point messaging system is, we will have two things. One is producer, one is consumer. We will have a queue. Something will go inside a queue and then it will be consumed by the consumer. But a key difference here is, once the data is consumed, it will be wiped from the queue. There will be no available instance of the data after the consumer reads the data. This is what messaging queues are. A famous example for this is RabbitMQ. Another method is PubSub method. There will be some storage place, which is our magic box. The producer will produce us to this and the consumer will subscribe from the magic box. So a key difference between these is, in the messaging queue or point to point, the data will be wiped, but in the PubSub method the data will not be wiped. It will be stored for some amount of time. That is the key difference between these two. If you wish to have a separate video on this, we will have later. So let me wipe this. So now, what are the use cases of Kafka? One, we can use it for messaging system. One, we can use for application log gathering. Another one is stream processing. As the name suggests, it's a streaming platform. So we are using for a stream processing. So then there are a lot more. We will create a project using the application log gathering use cases. So we'll discuss more on this in the later part of the video. So then, before moving further, why are we using Kafka? That's the question we need to answer. So before a decade, every company are using on-premise data centers, where they are majorly focusing on a monolith applications. In a monolith application, the data need not to travel much, which means the application itself handle the data. But once the companies migrated to cloud and they broke their service into microservice architecture, what happens then is, they need to travel the data a lot inside their architecture, which means, for example, let's see, if you are having a metrics dashboard, means this will be available for the team or the business analyst which needs some kind of data and need to process some data. Then we are having the client facing web application, means it will produce some data according to the customer's perspective. Then if you are having an analytic dashboard or analytic pipeline, means it needs to process some data. Then we will have our primary storage databases like MongoDB, PostgreSQL, and we will have our CacheDB as Redis. So in these things, data is the only thing which goes back and front. Let's see, if we are using the same approach as like in on-premise database, on-premise data store, means the data needs to travel like this. It will be a complete mess in a data in a architecture perspective. The data, there is a chance of losing the data. Imagine if my log dashboard is producing some data while traveling, the MongoDB cluster is having some outage, which means the data is lost. So to handle the data, to make sure the data is not lost, we need some kind of system that can take care of our data. So that's where Kafka comes in. So all the services or all the components of an architecture will communicate with the Kafka, and it will take care of the transportation part of the messages. So this is a high level perspective of what Kafka is, but it's worth knowing. So we'll end the slide here. We'll move on to the official documentation now. So here you can see this is the official documentation or official website of Kafka. We'll leave the links in the command so that you can take a look at different things which are discussed in this video. So we'll scroll a bit. Here we can see the core capabilities are its high throughput. As we discussed, it is around as low as 2 millisecond. It is high scalable. As we discussed, it can handle trillions of messages per day, and it has a permanent storage. As we discussed in the two messaging system, it will store the details of the message for a particular period of time. Then it is highly available. As we discussed, it will have an in-sync replicas. It is separated in a geographical region. So these are the things we discussed on the slides. So then we will have a separate video about the ecosystem because it is worth knowing what are the ecosystem around the Kafka, so that if you are in a project, if you are in a company who are building some Kafka related data pipelines or Kafka related architecture, means you can have the client libraries, you can have streams. So there is a lot of possibilities from these ecosystem. So we will have a dedicated section about ecosystem later. So then we'll go on to the docs. So here I need to share that this is the one we have discussed. An event is the fact that something happened. So as we discussed in the online transaction example, the event key is someone who made the payment. In our case, it's Riazur. Then the event value is from the made payment of $100 to Sanjay. The event timestamp is the date or time at which the transaction occurs. So this is how Kafka messages looks like. We will see how to streamline this, how to deserialize the serialized thing in the later parts of the video. So just keep an eye on this. If someone is interested in networking part, Kafka uses TCP protocol inbuilt. So if you have some time, you can explore the different things that it's using under hood, so that you can have a better understanding about Kafka. So if you are sticking with me till now, I'm having a thing to share with you. There is Kafka Summit happening on May 16 to 17. You can register for the Kafka Summit. There is a streaming pass. You can take part in the keynote. You can take part in the live stream. If you are in London, means you can get an in-person pass, which is around 799 euros. But streaming pass is more than enough for students who are starting their Kafka journey. So that's it for today, guys. If you like this video, make sure to subscribe the channel. So then I will share all the resources which I have discussed now in the comment section. So make sure to leave a like, subscribe to the channel. I will meet you on the next video.